Simulating heat distribution in a metal plate. Today, we're going to explore how heat distributes across a metal plate when different temperatures are applied to its sides. This simulation will help us understand how heat flows and how the temperature changes across the plate over time. Setting up the experiment. Imagine a rectangular metal plate. We'll apply different temperatures to each side of the plate and observe how the heat spreads. Here's how we'll set it up. Top side, let's set this to a high temperature, say 100 degrees Celsius. Bottom side, we'll keep this at a lower temperature, around 50 degrees Celsius. Left side, this side will be set to 75 degrees Celsius. Right side, we'll leave this side at room temperature, about 25 degrees Celsius. Observing heat distribution. Once we apply these temperatures, the heat will start to flow from the hotter sides to the cooler ones. Here's what happens. 1. Initial stage. At first, the areas near the hotter sides will heat up quickly, while the areas near the cooler sides will remain relatively cool. 2. Heat flow. Heat will begin to spread from the top and left sides toward the center of the plate. At the same time, the cooler sides will absorb some of this heat, causing their temperatures to rise gradually. 3. Steady state. Over time, the temperature across the plate will start to stabilize. The center of the plate will reach a balanced temperature, somewhere between the highest and lowest applied temperatures. Key observations. Temperature gradients. You'll notice that the temperature changes aren't uniform. The areas closer to the hotter sides will be warmer, while those near the cooler sides will be cooler. This creates a temperature gradient across the plate. Heat transfer. The heat transfer occurs through conduction, as the metal plate allows heat to move from high temperature regions to low temperature regions. Equilibrium. Eventually, the plate will reach thermal equilibrium, where the temperature distribution becomes stable, and no further changes occur. Why this matters. Understanding heat distribution in materials like metal plates is crucial for many real-world applications, such as engineering, designing heat sinks, engines, and other systems that manage heat effectively. Construction, ensuring buildings and structures can handle temperature variations without damage. Manufacturing, optimizing processes like welding or casting, where heat control is critical. Conclusion. This simulation shows how heat distributes across a metal plate when different temperatures are applied to its sides. By observing the temperature changes and heat flow, we can better understand thermal conductivity and design systems that manage heat more efficiently.